then we are using it as a counter. Okay. So we have seen the architecture of timer also, and we have seen there are different modules which are available into the timer. Okay. So in which the first mode is mode 0. So mode 0, it is 13-bit timer mode. So THX tracer and 5 bits from TLX tracer, these are used to set the count of 13 bits. Okay. So here the maximum count will be from 00000 to 1FFF. So that will be the maximum count which we can store using mode 0. For mode 1, it is 16-bit timer mode where all 16 bits, that is 8 bits from TH and 8 bits from TL, are used for 16-bit mode. After that, the third mode is auto reload mode. So in auto reload mode, what happens here? The same data or same count is available in TH as well as TL, and TL is used for counting. Okay. So here only one register is used for timer as well as for counter, and when it gets rollover or overflows at the time, the data which is available in the THX, that will get auto reloaded into the TL1. So here we need not require to again start the timer by providing the time count. Then the last mode is mode 3, that is split mode, where one register from TH and TL will be used for timer 0 and one for timer 1. So the mode 3 is available with timer 0 only, not available with timer 1. Okay. So that we have seen. After that, we have seen how to set the count into the registers TH and TL. Okay. So if suppose we want a specific delay, that specific delay will get provided by setting the count. So here we have the equation that the maximum count is FFFF. That will be the maximum count. So FFFF minus count plus 1. That is the equation which we can give or which we can use for setting the count. That means here this FFFF in terms of decimal values will be written as 65535 minus count, which is generated or which we can calculate it by using the internal frequency of timer and the required frequency or time. Okay, and plus 1. Okay. So that will be the equation which we can use for timer module, okay, or to set the count. Okay. Now let's assume we will take an example where we will use a delay of 5 millisecond or 10 millisecond to generate we will generate a delay of 5 millisecond. Now to generate the delay of 5 millisecond, here we will take XTAL frequency or oscillator frequency equal to 11.0592 megahertz. Okay. That will be the maximum frequency we will take. Okay. So it is megahertz. So here we will write the query or the question as generate delay of delay of delay of 5 milliseconds. We will take it as millisecond with the frequency of XTAL of 11.0592 megahertz. Okay. So that will be the frequency. Now using this frequency, we need to generate a delay of 5 milliseconds. So what does it mean? To calculate the delay, what we will do, we will take one port pin. Okay, so port will take port 0.1. That will be the pin which we will use to check the status of delay. That means for 5 milliseconds the port pin will be on, and for 5 milliseconds the port pin will be off. Okay, so we will toggle the port pin. Okay. Now here for setting this or to write this program, here what we need to do first, we need to set the count into the TMOD register. Okay. Then the next we need to use PH and PL register. PH and PL register. So here to set, first we need to select the mode. Now here if we want to provide the delay in the with 5 milliseconds, let's assume this mode we will take as uh, timer 0 with timer 0 with mode 1. Okay. Why I am taking mode 1? Because it is 16-bit timer mode. That means all the 16 bits from TH and TL registers are used for this mode. Okay. Now to select this mode or to set this mode, here we need to check or we need to consider this TMOD register. Now in this TMOD register, here the lower 4 bits are used for timer 0 and upper 4 bits are used for timer 1. Okay. So here, if we want to use timer 0 in mode 1, then TMOD register will be TMOD register. We will take this TMOD register as first is gate bit. See here, what we will do, we will take all these timer 1 bits. That is gate C oblique T bar M1 and M0 all are 0 because we are not using timer 1. Okay, so these bits are 0, 0. So these bits are 0, 0, 0, 0. Okay, then for timer 0, here we have gate C oblique T bar M1 and M0. Now this gate bit, it should be kept as 0. Okay, so D third bit will be 0. Then the next bit is C oblique T bar. Now, as we are using it as a timer, not as a counter, this bit should be 0. Okay. After that, for mode selection, see here for mode selection, these M1 and M0, these two bits are used. So for M1 and M0, if we are using 16-bit timer counter mode, the M1 and M0 status are 0 and 1. That means here the status will be 0, 1. So the count which we need to store into the TMOD or to load into the TMOD should be, these count should be 0, 1. Okay. So this will be the count which we need to store into the TMOD register. Okay. That will be the count. Okay. Now the next thing is here we need to do, after setting the TMOD register or taking the count as 0, 1 into the TMOD register, also we need to set the count in TH and TL. So here for TH and TL, we have the oscillator frequency 11.059. So using that 11.059 frequency, we need to set the count. Okay. So oscillator frequency given as oscillator frequency, it is given as 11.0592 megahertz. Okay. Now, from this frequency, we will calculate the time period for a single pulse. Okay. So here, this 11.0592 will first get divided by 12. Why it is so? Because in the architecture, we are saying that the internal oscillator frequency will first get divided by 12 and then it is used for timer. Okay. So here we will divide 11.0592. We will divide that by 12. Okay. So here we are getting 9216. Something is wrong here. 11.0 11 point is not active here, I think. 11.0592 divided by 12. So 0.9216. So here value is 0.9216 megahertz. That will be the frequency of a single pulse. Okay. Or what will say? This is the frequency which is required for timer module. Now, from this frequency, we will calculate the time period for a single pulse t. So t is equal to 1 by f. Okay. So which is equal to 1 divided by 0.9216 megahertz. Okay. That means here it will be multiplied by 0.9216 multiplied by 10th power 6. So it will come as 1 divided by 0.9216 equal to 1.085. So here it is 1.085, I think. 1.085. Okay, so 1.085, and it is in microsecond. That means multiplied by 10th power minus 6. Okay. So this will be the time period for a single clock pulse. Okay. Now, from the single clock pulse, what is maximum time which are or the delay which we are requiring? It is 5 milliseconds. Okay. So this 5 millisecond or the actual time delay required, that can be obtained by, or we'll write it as a small t. So actual time delay t is given by dividing the 5 millisecond by how much it is? 1.085 microsecond. That will be the from this we will get some count. So the count will be 5 divided by 1.085. So it is 4.608 into 10th power 6, 10th power 3. So the value will be equal to, given as, or just we will write here, 4.608. 4.608 multiplied by 10th power 3. Now, why it is 10th power 3? Here first it is 5 milliseconds. So it is 5 multiplied by 10th power minus 6. And it is 1.085 into 10th power minus 6. Sorry, here it is 5 into 10th power minus 3. Here 5 milliseconds. Or just we will write here 5 multiplied by 10th power minus 3. And it is divided by 1.085 into 10th power minus 6. So when we are doing this division, so this minus 6 will come to the numerator side, so it will be 6. So minus 3 plus 6 will be 10th power 3. So 4.608 into 10th power 3. So this value will be, we will write it as 4608. That will be the count, 4608. That is the count, actual count which is required. So here we will write actual count. Actual count is 4608. Okay. So it is in decimal number. So we need to convert it into the hex and we need to load into the register. So here this 4608 value will first get subtracted from 65536. Okay, so 65536 minus 4608. Now, why 65536? According to this equation, 65535 minus count plus 1. So, it is 65536 minus 4608. So, value will be 65536 minus 4608. It comes as 60928. So here the value will be 60928. Now this 60928 we need to load into the PH and PL. Okay. So before loading it here, we need to convert that value into the hex count, okay, or hex value. So here it is 60928. When it is converted into the hex, sorry, 60928, when it is converted into the hex, the value is EE00. Okay. So that is the value which is coming for 5 milliseconds. Okay. So the hex count will be EE. Hex count is EE00, in which this EE will get loaded into the TH0 register. Now see here we are taking timer 0. So here the register where we need to set the count will be TH0 and TL0. So in TH0 the count will be EE, and in TL0 the count will be 00. Okay, everyone got it? So this will be the count which we need to load into the TH and TL0. Okay. So this will be the initial process which we need to do. Now after that we will write a program. So first we will see in the assembly language programming, and then we will move towards the embedded C programming. So first it will be ORG0000H. Okay, basic. Now here we need to set the count. We need to set the TMOD register and TH0 and TL0. Okay. So here what we will do, we will move the contents into the TMOD register with the instruction move TMOD. Nah. So TMOD comma hash 01H. Okay, why? Because the TMOD count which we are getting is 01. Okay, so first we are selecting the mode in which the timer will burn. So move TMOD comma hash 01X. Now after that here we need to set the count for TH and TL. So the count is, we will transfer the contents into the TH and TL register with the instruction move TH0 comma hash 0x. What is the count for TH? It is EE. So 0xEE, or let 0EE 0EEH. Why 0? Because it is the character. So before the character we need to write 0. So it is 0EEH. Then we will move the contents into the TL0 with the instruction move TL0 comma hash 00H. Okay, so because here the value for TL0 is 00. Okay, now after setting the TMOD and TH and TL, here after that we need to set the event, or we need to generate the event, so that we will call the delay, and after that we will stop, we will clear the event, or we will switch the event. So that event we are writing here, or we have written here as port 0.1. So we are toggling port 0.1, right? So here what we will do, we will simply complement the port pin. Okay, so CPL P1.0. Okay. So we have complemented port 1.0 pin, and after that we will start the timer by using instruction set B. Okay. And what we need to set, see here, after TMOD register, the second register is TCON register, and in TCON register, the upper 4 bits are used for timer control. So TF and TR, these are TF1 and TF0, these are for overflow flag that will get set when the timer rollover takes place, and TR1 and TR0 are timer run control bits. That means when we set that particular bit, the timer will start. Okay, and when we will clear that particular bit, the timer will start. Okay, so here we need to set the TR bit of the TCON register. Okay. So here we have used timer 0, so we need to set this TR0 bit. Okay. So here in the instruction, here we will set TR0. Okay. Now after setting the TR0, the timer will start. Okay. And once the timer is started, we need to check the delay. Okay, or when the timer interrupt will get generated or overflow will get generated, and when it gets overflowed or rollover takes place in TH0 and TL0, here this TF0 bit will get set. Okay, because these are this TF bit, these are overflow bits, or when the count gets overflow, at the time this TF0 and TF1, these bits are setting. So for timer 0, this TF0 bit will set when the timer is over or when rollover occurs. So we will check the status of TF0 only. Okay. So here to check the status, we will use the instruction JNB, jump if bit is not set. Okay. Which bit? The TF0 bit. Okay. So we will write JNB TF0 comma back. Okay. And where we need to keep this jump? We need to keep the jump in the same instruction. Back. Now, why we are setting it in the same instruction? Because when the timer is started, unless and until this TF0 is set, the timer will run. Okay. And when the TF0 will set, we need to change the event or we need to stop the timer. Okay. So when this TF0 will set, what we will do? We will simply clear the timer with the instruction CLR TR0 and CLR TF0. Now, why we are clearing this TF0 also? Because once the bit is set in this TF0, when this bit is set, then what will happen? Here the timer interrupt will get generated, and once the interrupt will get generated, before serving that interrupt, we need to clear that interrupt because we need to use this timer again and again. Okay, so here we need to clear this TR0 bit as well as TF0 bit. That means we need to stop the timer and we need to clear the flag generated or timer interrupt flag. Okay, and to keep the process repeatedly, what we'll do, we will simply use unconditional jump as jump up. Okay, and where we need to give this up, we need to give this up to the TH0 because for every time we need to set the count. Because here rollover is taking place when the timer is when the timer starts and when the bit is set, that will get overflowed or this TH0 TL0 count is vanished. Okay. So here we need to again reset the count in TH0 and TL0. Okay. So these two counts are set, and here with the process will get repeated. Okay, and after that the last instruction will be end. Or simply what we'll do, S jump dollar, and then end. So this will be the program for setting the delay of 5 milliseconds using timer. Okay. So we will check here. Okay. So we will take the same program and we will load it into the no, here. So here we will just a minute. We have not stopped the program. Okay, so we'll write the program here. So here now we are checking the program into the queue. So here I'm giving the name timer 0 mode 1 dot asm, and we will add it into the source board. Timer 0 mode 1. Okay. Now we will check, or we will build it undefined symbol move th 0. So th 0. Okay. So here now we will the program is built. Now we will run the program. Sorry, some problem I think might got occurred here. Okay, now see here, when we build debug the program here, we need to check the status of port pin, right? So port, which port we are using? Just 1 minute. What ascending? Remove the program. We will add the timer program here. Okay, so okay, so there are 0 errors. Now we will debug the program. Okay, now see here, to check this timer here, just we need to go into the peripherals. We need to open IO port. Which port we have taken? Port 1. So port 1 we need to take. Then we need to check the status of timer also. So timer 0 mode 1 we have taken. So you can check here. Okay, and to check the status of this port 1 also you can check it, but in the logic analyzer. Okay, so here this logic analyzer we will take separately. Okay, now see here, this logic analyzer we need to make the setup in logic analyzer. So go into the setup here. Just you can see here the dotted box. Okay, so click on it, and as it is port 1, so just write port 1.0 and click on enter. Now see here, this port 1.0 pin is added into this logic analyzer. Okay. After that, you go with the single stepping, so that to check the status of this TH0, TL0 and PMOD, and then we need to run the program. Okay, so see here, first PMOD mode is 01. So see here in this timer counter module, you can see TMOD value is 01. Okay, that means here mode is 16-bit timer counter mode. Okay, then the next is TL0 value is 00. See here, this TL0 value comes as 00. Then TH0 value is EE. So here TH0 is EE and TL0 is 00. Now we're complementing port 1.0 pin. See here, the pin is getting complemented here. Okay. After that, what we'll do? Just we will run the program. So you can see here this pin, or you can. So this pin is toggling continuously 10 10 10 and so on. Okay. And here when you stop the program, I think there is some problem in setup. Right. Port 1.0. Port 1.0. Okay. Now see here in this logic analyzer you are getting this window. Okay. So when you are running the program, see here for every 5 millisecond delay, here we will get the higher pulse. After that, we are getting the lower pulse. Okay. You can calculate the value here also in this logic analyzer. So here you can check here 24.02859 seconds, and here it is 24.03091 seconds. So if you subtract it, then you will get the delay in between this delay for the lower level. Similarly, the same delay is available for higher level also. Okay, so everyone got it. So this is the way of writing the program. So while you are writing the program in assembly language or in embedded sim, here to check the status of timer, here just click on peripherals, open the port to check the event, then again click on peripheral, open timer counter module, and then after that you can execute the program. Okay. Now this is one way of writing the program. Now if suppose you have been asked to generate a delay of, or simply here we will write here, generate delay, or we will write here as on time of 2 millisecond and off time of 5 millisecond. So here, what does it mean? Here in the same program, okay, whatever we have written, see here when we are setting the delay, the same delay is used for complementing port 1.0 pin. That means for the same time, or for 5 milliseconds, the port pin is on or high, and for the same 5 millisecond time, the port pin is off or 0. Now here in such a cases, here we have on time of 2 millisecond and off time of 5 millisecond. That means there are two separate delays we require. Okay. So in this case, either you can use two separate timers or you can use the same timer by setting the different count. Okay. Now, for example, if suppose we are taking tmod or timer 0 in mode 1, then here the value of tmod will be 0 1. Okay. But here if we take the value for on time and off time, the value of ph and tl, that will get varied. So here for on time, we need to calculate separately. So this on time will be having separate ph0 and pl0. At the same time, for off time also, we need to write, or we need to give separate count into the ph0 and pl0. Now, see here in this previous program here, what we have done, we have set the count into the TH and TL by using oscillator frequency 11.0592 megahertz. Okay. So according to this, we have calculated the actual time delay of 5 milliseconds. That is, the count is 0, 0 and E. Okay. So simply here also what we will do, for off time, we will take the value as it is 5 milliseconds. So we'll take the value as T0 is PE, value for T0, that is PE, and for TL0, the value is 0, 0. Okay. Now for 2 milliseconds, here what we need to do, like here, what we have done for actual time delay, we have divided the frequency time delay by the actual, that is 5 millisecond by 1.085 microsecond. Okay. So here also we'll do the same process. We will divide 2 by 1.085. The value comes as 1.843. So the value is 1843. Right. So this we will subtract this 1843 from 65536. Okay. So here what we'll do, we'll take separately here. Actual count is 1843. 1843. Okay. So here also the equation will be or the count will be 65536 minus 1843. So the value will be 65536 minus 1843. Value is 63693. So it is 63693. Everyone is getting it? अरे समझ लक्षात येते का?
सर
हाँ बोला बोला.
त्याच्यामध्ये ऍड 1 करायला पाहिजे ना?
सी हिअर
ऍड 1 करायला
नाही, हे बघा इथे मी काय सांगितलं, इक्वेशन काय आहे, 65535 मायनस काउंट प्लस 1. लक्षात येतं का? हा काउंट आहे तो 65535 आहे, प्लस 1 काय झाला 65536. तीच व्हॅल्यू आपण इथे घेतलेली आहे. दिसतं? आर यू गेटिंग इट?
ओके सर.
लक्षात आलं का? दॅट मीन्स इट इज 65535 प्लस 1. हा. Okay. So it is 63693 for 2 milliseconds. Then we will convert it into the hex. The value will be 63693. 1 minute. Programmer mode we need to take into the decimal 63693. When we convert it into the hex, it will be F8CD. Now the value for 2 millisecond will be TH0 will be equal to F8CD. Na? So it will be TH0 will be F8 and TL0 will be CD, I think. F8CD. Okay. So this is the value for 2 milliseconds. We'll convert it here. So for 5 milliseconds we have this value. For 2 milliseconds we have this value. Now here what we'll do? We will use the same program by making slight modifications. Now see here, we will give on time TH0 equal to F8. सगळ्यांच्या लक्षात येते का? And TL0 will be CD. Now see here, in this program, ORG 000H will be same as it is. Move tmod equal to 01 same as it is. Okay. Now here we will make slight modification. So first value is we are providing for on period, that will be TH0 is equal to 0 F8. Okay. And TL0 will be CD. It will be 0 CD. Now here, instead of complementing this port, or simply we will change it. We will change the instructions. Okay. So this is the count, or we have provided for on period. Okay. So here, what we will do after setting this count, we will just set B port 1.0. So we are turning on the port 1.0. Okay. Everyone is getting? सगळ्यांना लक्षात येते का? हा ऑन पिरियड आहे, तो चेक करण्यासाठी काय करतोय मी पोर्ट 1.0 सेट करतो. ओके. सो आफ्टर सेटिंग पोर्ट 1.0, what I will do, I will simply call here, I will call or absolute call, a call delay. A call delay. I am giving the name delay. Okay. सर्वांच्या लक्षात येते का? सी हियर इन द मेन प्रोग्राम, हा जो आपण टायमरचा प्रोग्राम लिहिलेला आहे. सो हियर वी हॅव जस्ट कॉम्प्लिमेंटेड द पोर्ट पिन अँड वी हॅव स्टार्टेड द टायमर. Okay. After that, we have stopped the timer by checking the TF0 bit, right? So here we are having the same delay, but in this program we have two separate delays, one for on period and one for off period. Okay. So what we will do, we will write the instructions for starting the timer and stopping the timer separately by giving some different name or by calling the subroutine. And in the main program, what we will do, we will only set the count for on period and off period. Okay. So just first see here, we will call a delay. Just I am giving the name delay to that particular subroutine because these are required for two times. Now, one for on period and one for off period. Okay. Now, for second off period, we will again set PS0 and PL0. Okay. So here value will give as PS0, comma move PH0, comma, what is the value given? 0 EEH. And move PL0, comma H00H. So this is for off period. We are setting the count into the TH0 and PL0. Okay. Then we will simply again write or call delay. A call delay. Okay, and when it will return back, then we will keep the process repeatedly. Okay, so as jump up, we will write as jump up, and up will be again given to this instruction. Okay, everyone is getting it. See here, what we have done, we have set the count for on period, we have set the count for off period. Okay, and in between the on period and off period, what we are doing, we are just starting the timer and stopping the timer. So whatever the starting and stopping of the timer instructions are required, these instructions we will write separately and we will call that instructions into the main program. Okay, so here after that we will write the subroutine. So here we will write org 0 0 30 or 0300. That will be the initiation of the program. So we need to initiate the memory location also now. So where the program is available. Okay. Now here we will write the delay. So in this delay subroutine, what we will do? Just we will set that TR1, set B, sorry, TR0. Yes. So we'll just set bit here. We will start the timer 0. After that, we will check the status of timer 0 with the instruction J and B. Okay. So J and B TF0. So unless and until this TF0 is set, it will remain in the loop here only. And when it is JNB set or TF0 is set, what we need to do? Only we need to clear PR0 and clear TF0. And after that, we will return to the main program. Okay. And after the completion of program, just we need to write in. Now, if you see this program, here what we have done, in the main program only we have set the count for on period and off period. Okay. And the repeated instructions required are starting the timer and checking the status of TF0 and stopping the timer. So these instructions we have written separately into a subroutine, and we have called that subroutine into the main program. Okay, for on period also and for off period also. So here for on period also we have called the subroutine, and for off period also we have called the subroutine. Okay, and this process is repeated for infinite time. Okay, everyone got it? अरे सर्वांच्या लक्षात येतं का? Now we will check this program into the into kill. Okay, so this program we will take, we will write into the same program here. What are the errors? Move th0, 0 f at th0, 0 f at recall delay. Should be recall delay. H0E. Now we check. Which port we have taken here? Port 1.0. Okay. So first PMOD 01. Here the count in PH0 is F8 and PL0 is CD. Okay. Set B move delay or call delay. One instruction is remaining in this program. Okay. So here we have set the port for for 2 millisecond. After that, here we need to clear port pin. Okay, so this instruction is missing. Clear port 1.0. Okay, so the same program is available here. We'll take the port 1, right? So port 1 will take here. Then timer 0 we will take here, and we will use logic analyzer. In the logic analyzer, we need to set the port 1.0. Now see here, for on period and off period, here we are getting different delays. I think this, see here, on period is of 2 milliseconds and off period is of 5 milliseconds. Are you getting it? अरे सर्वांचे लक्ष देते का? So here on period is of 2 millisecond and off period is of 5 millisecond. So here we need to set the separate count for on period as well as for off period, and the instructions which are required or repeated, that is starting the timer and waiting for TF0 to set and to clearing the timer and TF0, that we have written into the separate subroutine and we have called into the main program. Okay, so in the previous instruction, in the main program itself, we have started the timer and stopped the timer, because on period and off period is same, or the same delay is provided into the program. But if you have different delays, here we need to set different count for this program. Okay. Everyone got it? Okay, so I think this will be